Hello all, welcome back to Electronic Devices and Circuits video lecture series. I am BVV Satyanarayana, Associate Professor in Department of ECE, Vishnu Institute of Technology, Bhimavaram. In unit number 5 of EDC, Transistor Biasing and Thermal Stabilization, we already discussed about need of biasing, DC load line and analysis, and operating point. In this video, we will discuss about criteria for fixing the operating point, means selection of operating point for amplifier. The objectives of this lecture are selecting the operating point for amplifier, effect of operating point on amplifier output, and the maximum input signal that an amplifier can handle based on operating point. The selection of operating point is very important for amplifier circuits for proper operation. The input junction must be forward biased and the collector junction must be reverse biased so as to operate the transistor in the active region. And in this region, the transistor, it can be used as an amplifier. For that, a load resistance RC or RL must be connected in the collector circuit. And amplified AC output signal is developed across the load resistance RL or RC. Corresponding to this RL or RC and the given supply voltage VCC, we are getting a DC load line, and that DC load line can be shown in the below figure. And the operating point must lie on the DC load line depending on the base current. So here in this case, I am assuming the operating point at 3 different locations. That is at point A, B or C. And out of these 3 points, I am trying to find out the best operating point location. And this diagram represents the output characteristics of transistor with DC load line. So our operating point must always lie on the DC load line. At 3 different locations, I am assuming the operating point, and based on that, I am trying to explain the best operating point location. So first point A, which is nearer to the saturation region, we can assuming as a operating point. And in the second case, we can assuming the operating point at position B, which is close to the cutoff region. And in third case, we are assuming the operating point at point C, which is in the middle of the active region. So let us consider which one of the which location is most suitable for the operating point. So after DC conditions are established for the amplifier circuit, an AC input signal is applied to the amplifier, and this AC input signal is superimposed on the DC voltage so that we are getting an amplified output signal across the load. Here the input signal IV varies sinusoidally, and hence the output current IC and output voltage VCE also varies sinusoidally. Then we are getting an amplified AC signal at the output. The variations of collector current, collector voltage for a given base current can be represented on output characteristics. So I already told with 3 different cases, I am trying to explain the best operating point location. So in first case, I am assuming the operating point is at A, which is near to saturation region. So these are the output characteristics, and I am assuming the operating point is at location A. Then at this instant, we are applying our input signal. This is the input signal IB, which varies sinusoidally. And for this input signal, at positive peaks, at positive peak for this period, the transistor is operated in the saturation region, which is nearer to the saturation region. So for this shaded area, the transistor is operated in saturation region. So in saturation region, even though IB changes, there is no change in IC. The IC is constant at saturation value, and hence we are getting a clipping at positive peaks. If you project all these lines onto the y-axis, then we are getting the output current IC. In this, there is a positive clipping. Positive peak, it is clipped. And if you project all these lines onto the x-axis, then we are getting a VCE. And for VCE, negative off cycle is clipped out. Since there exists 180 degrees phase difference for CE amplifier, so we are getting a clipping in positive of VCE. So amplifier must amplify the input signal without any distortion. Here, for a small portion of the input signal, the transistor is operated in saturation region. So we are getting a positive clipping. So point A is not suitable operating point because of clipping at positive peaks. So it is not the best location for operating point. Then second case, I am assuming the operating point at location B, which is near to cutoff region. This is the location of operating point now, which is intersection of IB and DC load line. Now we are applying the input signal IB. And for this IB, for this portion of the input signal, for this negative portion of the input signal, the transistor is operated in the cutoff region. So in cutoff region, the current is equal to 0, or which is very, very small. That's why there is a negative clipping in IC. If you project all these lines onto the y-axis, there we are getting a IC, and this negative peak, it is clipped out. So for this portion of the input, even though our IB changes, our IC, it remains constant at IC naught. So that's why we are getting a negative clipping. So since it's a CE amplifier, there exists 180 degrees phase difference. So we are getting a positive clipping in the output voltage VCE. So since there is a clipping for output current and output voltage, we are getting some distortion if the point B is the operating point. So we can say point B is not suitable operating point because of clipping at negative peaks. Then I'm assuming the third case. In third case, Q point is at position C, which is the middle of the active region. Then this is the operating point, which is the middle of the active region. Then we are applying our IB. Then for this IB, since the operating point is in the middle of the active region, for complete positive off cycle and complete negative off cycle, the transistor is operated in the active region, and hence no clipping in IC and VCE. So there is no distortion at all if the operating point, it is in the middle of the active region. So we can say point C is the most suitable operating point because of no distortion in the output. So out of these 3 points, C is the best location. Means if we want to use the transistor as an amplifier, the operating point should be in the middle of the active region. Yeah, even the operating point is at C, means middle of the active region, then distortion can also occurs in the amplifier if the input signal is a very large signal. If you apply a large signal, then even though the operating point is at C, and for this positive peak, the transistor is operated in the saturation region. So positive portion, it is clipped out, positive peak, it is clipped out. And for this portion, the transistor is operated in the cutoff region. So the negative peak it is clipped out. So means even though the operating point is at C, middle of the active region, because of very large input signal, for positive peak, the transistor is operated in saturation region and positive peaks are clipped out. And for negative peak, the transistor is operated in cutoff region so that the negative peaks are clipped out. Means if you are applying a very large signal, then we are getting distortion because of both positive and negative clippings. So for amplifier in general, we are applying a very small signal. That's why if you select the operating point in the middle of the active region, so for complete positive off cycle and for complete negative off cycle, the transistor is operated in the active region and hence no distortion at all. We are getting distortion if it is a very large signal, and amplifier case, we never applied a very large signal as the input signal. So based on this, we can explain the maximum signal that can be handled by the amplifier. So which is decided by the choice of operating point. So that can be represented in this diagram. Here I am representing the operating point at the middle of the active region, that is C. Then this is the maximum input signal, base signal that can be applied to the amplifier. So for complete positive off cycle, the transistor is in active region, and even for complete negative off cycle also the transistor is in active region. So we are getting IC, output current, without any distortion, and we are getting VCE also without any distortion. So this is the maximum signal the transistor can handle, that is decided by the operating point. If you are applying a signal which is larger than this signal, definitely for positive peak it is operated in saturation and that portion is clipped out, and negative peak it is operated in cutoff region, that portion is also clipped out. So this is the maximum signal handled by the transistor, that depends on the operating point. So likewise, we can explain the selection of operating point. So once the operating point is fixed, it must be stable. I fixed the operating point in the middle of the active region, which must be stable. Suppose if that operating point is moves towards the saturation region, then there may be a possibility of positive clipping. If the operating point is moves towards the cutoff region, then there may be a chance of clipping the negative portion. So the operating point must be fixed in the middle of the active region and it should be stable. It must not move. Then coming to the summary. In this lecture, we have learned the following: selection of operating point for amplifier and the effect of operating point on amplifier output. Then fixing the maximum input signal that the amplifier can handle. Thank you. Thank you all.